Hello, my name is Curtis. Today we will be discussing neurodegeneration and its potential remedy in human and artificial neurons. We all have loved ones that dies due to Alzheimer's disease. Why does it happen? Is there any way to change it? Mitochondria is the powerhouse of a cell. It can use to create ATP, and it can also activate caspase-8, which allows cells to destroy itself. Mitochondria also creates ATP as a side product. Excessive ATP can lead to attack in mitochondria and thus reducing ATP production. If a cell loses too much ATP, it will implode itself and dies. This is referred to necrosis. Excessive ROS can also attack surrounding proteins, which leads to misfolding of protein, which is toxic to cell. It activates the NMDA reactor and causes influx of calcium, which leads to overactivation of caspase-8. It leads to self-destruction of a cell, which is known as apoptosis. Artificial neural network can also contain faults and error. For instance, glitch in hardware can lead to noise, software complication can induce error. Noise and error can cause the artificial neural network failing to perform its designated task. For the purpose of this chart, a noise probability means the percentage of a neuron is damaged in an artificial neural network. And a noise level of 0 means the neuron output nothing but 0. As you can see, the accuracy of the neural network does not drop dramatically until the probability is above 60%. This is an important observation as it explains why neurodegeneration can happen earlier in its life stage, but the symptoms of the neurodegenerative diseases does not show until the neuron death reaches a critical level later in life. Alzheimer's disease is correlated to hippocampus neuron death. It is responsible for the formation of new memory. When neurons in the hippocampus dies, the brain suffers from generating new memories. This explains why many Alzheimer's disease patients retain memory of their younger age, yet they fail to remember newer memories. Substantia nigra is a part of brain responsible for releasing dopamine to the movement, producing part of the brain like frontal lobe and basal ganglia. It causes patients to shake and can no longer maintain their movement when neurons in the substantia nigra is dying. It is known as the Parkinson's disease. Similarly, Huntington's disease is also caused by death of brain cells. Although with similar symptoms to Parkinson's disease, it is caused by genetics, which creates excessive CAG, the kind of protein that is toxic to neurons. Stem cells are cells that can become any type of cell in the body. They can even be a replacement of dead neurons in the brain. The replacement stem cell requires proper structure to attach and grow. It can then be seamlessly integrated to the main neural network. Similar to a previous demo, we can simulate neural repair with the help of artificial neural network. For the purpose of this chart, neuron access density means percentage of neuron we have access to repair. As you can see, even only with 10% of neuron access density, we are able to double the accuracy. This tells us as long as we are able to repair the neurons of a brain below the critical level, we can potentially see big improvement in the brain function. Alternatively, we can also proactively build neuron death resiliency by various methods and architecture. For instance, we can identify critical neuron in a cell and duplicate it and halve the weight of its respective output. We can also artificially inject noise and faults during training to improve the accuracy of a neural network under fault stress.